Okay, this is the identity function. And I know you guys remember making an XY table to graph with. So if I just picked some very simple x's, and if the equation tells us that y equals x, if x is -3, what's y?
-3.
Negative, they're equal. And the same thing will be true with all these numbers if x is equal to y. Another way to look at this is, I'm sure that you are familiar with slope-intercept form, am I right?
Yes.
You guys remember slope-intercept form? Alright, if I take this equation and I write it in slope-intercept form, tell me, what is m? What is the number in front of this x? Understood to be? 1. What is the number added here since nothing's there? Since nothing's there, what's the number that you would
0.
put? 0. Okay. Now before Thanksgiving, we graphed some lines with a point and a slope from slope-intercept form. Do you guys remember what B represents on the graph? It's called the slope-intercept. So it's the y-intercept, okay? Now the y is 0 right here at the origin. And if this thing has a +1 slope, how do we graph that? Well, there's a couple ways we can write it, right? We can say that, you start to tell me. You go where? You go up 1 and to the right. Or you go down 1 and to the left. You guys remember that? Alright, well now look at my table. Isn't that the same points that I just had written down over there? -3, 3, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, 3, 3. Same thing I had there. I just graphed it with slope-intercept form, or I could look at that table.
Cool.
They're the same thing.
So probably you use the table as a cheat sheet for this.
Yeah. And when I tell you that we're going to have a test on this, do you think you need to know the table?
Yes.
Yeah, you do. You're not going to know where the
It tells
text
you
is.
exactly what to do, you just have to do it.
Alright, so let's draw us a line. And that is the identity function. That's the identity function. Okay. That wasn't too bad. That is a linear equation. Do you remember before Thanksgiving we did a linear equation has an x and or a y. They're to the first power. There's not any square roots or absolute value bars. They're not multiplied together. Variables not in the denominator. Remember all that. That's why we define linear equations. Well, look at this equation here. I've got an x and a y, and they're to the first power. So it makes sense that this would be a line when I graph it, or a linear equation. All right, on to the next one. Is a quadratic function. Y equal x squared. So you're going to write y equal x squared. And on this one, this graph only had the first couple of quadrants, I believe, right? Wasn't it to 10 to the right, 10 up, 10 left, okay?
Yeah.
Now this is not a linear equation. You know why? X is squared. Remember, with a linear equation, I have an x to the first power, right? Y'all with me? This is x squared. I'm not going to need my ruler to graph this one. This one went left 10, up 10, and right 10. They should have been in order. Okay. All right, so I can't do slope-intercept form. So what I have to do here is to do a table. I'm going to pick the same numbers.
Are you just picking?
I'm picking the easy ones. That's what I'm picking.
Okay.
Easy to graph. What happens to a number when you square it? It becomes bigger, but it becomes positive, doesn't it? Is there any way that I could square a number, or in other words, multiply it by itself, and I wouldn't get a positive?
No.
Like, what's -3 times -3?
Negative or positive.
Positive 9. What's +3 times +3? Also 9. Is there any number I can multiply by itself to give me a negative? No. That's why I only needed the first couple of quadrants where y is positive because everything I squared is going to be positive. So negative 2 times negative 2 is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So I filled out my table. Yes, sir.
Where do you get that from?
These x's,
Yes.
good question. I just tried to pick numbers that were easy for us to square and easy for us to graph. That are small numbers. You know, I could put 100 on there, but when I square it, it's going to be 1,000. So I didn't want to graph that. So I picked me some small numbers that would be easy to graph. All right, negative 3, 9. Negative 2, 4. Negative 1, 1. 0, 0. 1, 1. 2, 4. And 3, 9. Now this is not a line. It's a curve. So you have to freehand this. And it's not a V shape, it's a U shape. So do your best. You guys are better artists than I am, and just draw you
Oh goodness.
a curve. And hopefully it looks better than mine. I'm very sorry about that, but it's just round it off, okay? Now this equation is a quadratic equation, but this graph is called a parabola. Parabolas are everywhere. Think about a satellite dish and the way that they are shaped. Think about going to the gym and shooting a basketball. With force, you push that ball up into the air. It reaches its highest point, which is like on the it's like a parabola, you know, that's terrible. It's like a parabola that's turning down instead of turning up. It reaches its highest point about 2/3 of the way toward the basket, and gravity pulls it down right into the basket for a 3-pointer, right? Think about shooting a gun. The force in the gun pushes the bullet or the shell out, and then all the time it reaches not a very high height or anything, but it reaches a certain height, and then what's the force that begins to pull it back down? If it hits not a tree or a deer or anything, gravity pulls it back to the ground. It doesn't just go along and go whoop, right? It doesn't suddenly fall, but it horizontally, it travels until it finally hits the ground. Anything that's projected, think about turning on the water fountain and watching the water come out, and it forms a parabola. So anything that's projected out and up, the force behind it pushes it up and out, but then gravity starts working on it again, doesn't it, and pulls it back down. So parabolas are everywhere, and they're very, very useful. All right, y equals a number. Now this C just represents a general number. Any number, could be anything. I believe this one is a little 5 by 5 that you drew. Is that right?
Yes.
You just drew very simple. All right, now what does this mean? This is a linear equation. I've got a y to the first power. This is y is 2. Okay. Well, it doesn't matter what x is. Y is 2. All right. Negative 7, 2. Negative 3, 2. 0, 2. 3, 2.
We only went
8,
5.
2. Okay. But my point
Still.
is, still, good point. But still, what kind of line form there, guys?
Horizontal.
Horizontal. So if I've got, whoops, that's not a good color. If I have y equals a number, I'm going to have a horizontal line. That's it. Now, graphically, that is called, or the equation is called the constant function. Doesn't matter what x is, y is constantly 2. The graph is a horizontal line. Y equals a number. Now, so far, everything that we've graphed, we graphed the identity function, we graphed the quadratic function, we graphed this horizontal line. Do they all pass the vertical line test?
Yes.
They are all what?
Functions.
Functions. They're all functions so far. I even called them that. I called them the identity function, the quadratic function, the constant
That
function.
should have been the dead giveaway that they were all functions.
That's right. It should have been, shouldn't it? All right, but this one is not a function. I'm not going to give it a special name because it's not a function at all. Okay. Now this is another little 5 by 5 that you drew.
Miss Green,
Yes, sir.
the last graph, what was the, like x equals, how that one's x equals c, what was the last one?
Y equals 2. Alright, now this one is a whole lot the same, that last one, except it's saying x is negative 1. So x is negative 1, negative 1, 1, negative 1, 4, negative 1, negative 2, negative 1, negative 5. Negative 1 is x. What kind of line just formed? What kind? It is a vertical line. So you can use your ruler on this one. It is a vertical line. Now, graphically, I have a vertical line. But I do not have any kind of function. Remember, the vertical line is the only line that is not a function. Definitely wouldn't pass the vertical line test. I mean, how many points would I hit if I drew infinitely many, right? So I did them all. There's no way that's a function. It's not too bad so far, is it?
No.
Alright, the next one is the square root function. Now the square root function, guys, we drew it across 16. If I'm correct there, we drew it across 16 and we just went up 4. Alright, so I'm numbered to 16 here and I'm up to 4 also. So let me ask you a question. What is the smallest number? You have to think about this. What is the smallest number that has a square root that is a real number?
I don't know.
Like on your calculator. I want everybody to see this. So if you have your calculator, I want you to see. Take the square root, just for the argument of it. Take the square root of negative 4 on your calculator. Dig it out of your bag,
Can I borrow a calculator?
and you will see. What does it say?
16.
Now don't hit x squared, hit the square root.
Thank you.
You should have error, domain error, syntax error, or maybe just an E. Look guys, it's not this, it's above there. It may be like this, that's your button, and this symbol is above it, so you have to hit second or shift to get to there. You want this symbol right here. Alright, you know why it gives you an error? Does everybody get an error? Here's why. Think. What would I multiply by itself to give me negative 4? Like negative 2 times negative 2, is that negative 4? Okay, what about positive 2? Is positive 2 times positive 2 negative 4? Is there a number that I can multiply by itself and give me negative?
No.
Okay, not a real number anyway. Those numbers exist and they're called imaginary numbers or complex numbers. But as far as we know, all we're thinking about are the numbers that are on the number line. And those numbers are what we call real numbers. Okay? Those other numbers are real also. They're just not, by definition, real numbers. They're called imaginary numbers, but it's not like Tinkerbell, you know, it's like they're actually numbers. Alright, so
Miss Green.
okay, what is the smallest number that we can take the square root of and get a real number for him.
Oh.
4.
0.
0. What'd you say?
I said 4.
4 is a perfect square. What is a perfect square between 0 and 4?
2. No, that
3.
1. Yes.
So this is 0 times 0, 1 times 1, 2 times 2, what's 3 times 3?
3
Nine.
is
No.
9.
Now I could put 2 and 3 and 5, 6, 7, 8 in there. But when I take their square roots, I'm going to get decimals. And we could graph those. We'd be fine with that. But these are called perfect squares. Because the square root of 0 is
0.
0. The square root of 1 is,
1.
square root of 4 is,
2.
square root of 9 is
3.
3. Alright, let's also do 16. What's the square root of 16?
4.
Let's graph. Let's graph what we've got. Alright, here's 0, 0, 1, 1, 4, 2, 9, 3, and 16, 4 on this graph paper over here.
Perfect.
I'm not looking at these boxes, guys. I was looking, up here. All right, so this is half of a parabola, really, is what it is. That's not too good. You guys got a better looking graph than I do, but it is half of a parabola. So we're going to make it a curve.
Oh.
That's terrible looking. But listen, this doesn't have an arrow at the origin.
That was terrible. Yeah, like terrible.
I'll try again. Sometimes I do better going from right to the left.
It's a good idea.
Where's it to? Good looking. That's good looking.
What did you just say?
Good job. So 4 is it 2?
Mine still looks weird.
Oh, goodness. When you draw that, and there's 1, 2, 3. The one's not down here. That's 0. That's what makes it 0. Good looking. All right. There we go. All right.
Just like me.
Just like, yeah. All right, so we got an arrow on this end to show that it goes infinitely in that one direction. But this does not go anywhere. It starts at 0, 0 is the smallest perfect square. It can't, like, don't do this. I think it do. Drives me crazy. They'll just, I'll put something down there. Like it doesn't. Because those are not perfect squares. So it starts at 0. All right. What was this one of?
The
This was first two quadrants to 10.
no 5. 5.
Oh, I did. It's just 5. Okay. This is the absolute value function. The absolute value function. Bless you. What do you know about absolute value? If I take the absolute value of a number, what comes to mind?
Positive.
Positive. So that's why I only need these two quadrants where y is positive. All right, I'm going to make me a table here. I'm going to use some pretty small numbers just to get a good idea about what the graph's going to look like. So when I take the absolute value of -3, what do I get?
Positive.
Positive 3. How far is -3 from 0 on the number line? It's 3 units. And then the absolute value of -2 is 2. The absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. 2 is 2. And 3 is 3. Now we can use our ruler on this because this is a V-shaped graph, okay? So -3 is at 3. -2, 2. -1, 1. 0, 0. 1, 1. 2, 2, and 3, 3.
Mine's gonna be butterfly.
And so use your ruler and make this array going this way. And then array going this way. Now when you see absolute value, hopefully you'll hear the V sound and know that it's a V-shaped graph, okay?
Ooh, thanks.
Absolute values of V. You have 6 in all now?
Yes, ma'am.
Okay. I want you to look over them for just a few minutes and see if you can become kind of familiar. This one is called the cubic function. Why? Because this is y equal x cubed. Up to the third power, right?
Be on the test.
This is a bonus.
Oh.
Alright, I'm going to give you some numbers. And I want you to use your exponent button, which either looks like this, or this, or this. Now, it's not the y, it's not the x squared button. Now, I'm going to come around and let you point to this button on your calculator. It's one of these three, okay?
You
Well,
should.
you know what,
Alright, so here's our table completed. Now, I don't think we're going to be able to graph -3, -27 unless we maybe some tape, some graph paper together, but I just want to show you how quickly this graph gets big, gets huge, alright? So, I've got -2, -8. -1, -1, 0, 0, 1, 1, 2, 8. Now, from there, think about it. Don't do anything yet. Just do what you want. Stop. You're good so far. But start with it. If I did 327, I mean, I'd be way up here on the wall.
Mm-hmm.
What's 4 cubed? Look on your calculator. Try it and see. 4 cubed,
64.
64. So at 4, I'd be up there at 64. All right, what's 5 cubed?
125.
At 5, I would be past 100. So this thing shoots up to positive infinity and down to negative infinity quickly, okay? Now this curve, do your best. Do your best because I call it an S curve. I'm not mad anymore for this one.
That was the worst.
Yeah, I've done.
And then I've got an arrow here and an arrow there. Alright, so let's graph that one. Whatever. Like this. Instead of U2, it just goes down like this. So this is y equals x to the third. Okay?
I feel like that was
Alright, y'all have a nice day.